Welcome back. Today, we're stepping into the Cybersecurity Command Center to wrap up the CIA Triad with its third and final pillar, availability. We so often think of security as just locking the doors and keeping the bad guys out. But what if the people who actually need the data simply can't get to it? So today's explainer is all about how availability literally keeps our digital world running. Seriously, take a second and imagine the sheer chaos if hospital systems, your online banking, or an entire cloud platform just vanished. What happens when critical systems go dark? It's way beyond just a minor inconvenience, right? Operations grind to a halt, revenue bleeds, and honestly, panic sets in. That is the very real threat we're defending against.
Okay, let's dive right into this. Availability is basically the absolute guarantee that users can access IT systems, applications, and data exactly when and where they need them. It means your online banking app actually opens when you tap it. It means doctors can pull up life-saving patient records instantly, with no spinning wheels. It is the core promise of uninterrupted access for authorized users.
Section 1. The stakes. Chasing 5 nines.
So, when cybersecurity engineers talk about the absolute gold standard of high availability, you'll hear this phrase a lot, the 5 nines. It's actually a standard we inherited from the telecommunications industry, and it literally means that a system is available and operational 99.999% of the time. Now, to put that into perspective, what does that percentage actually translate to in the real world? Well, to maintain 5 nines, you are allowed a shockingly brief 5.26 minutes of downtime per year. Just really think about that for a second. You have less than 5.25 minutes annually for a system to be offline before you completely fail that metric. No pressure, right?
So why are we so absolutely obsessed with 5.25 minutes? It all comes down to the blast radius of downtime. Our heavy reliance on digital services means that even a super brief outage ripples out to cause massive damage. We're talking about severe financial losses, extreme customer dissatisfaction, entirely altered business productivity, and of course, long-lasting reputational damage. When the system is down, every single second counts.
Section 2. Threats to uptime. What takes systems down?
Surprisingly, a massive portion of the threat is entirely physical. According to the Uptime Institute Global Data Center Survey, an astounding 45% of impactful outages are caused by power issues. We're specifically talking about things like uninterruptible power supply, or UPS, failures. So sometimes, the biggest threat to your cloud data isn't some highly sophisticated hacker in a hoodie. It's just a faulty power transfer switch sitting in a physical data center.
But of course, the digital threats out there are absolutely relentless. Malicious actors actively try to destroy availability through distributed denial of service, or DDoS attacks. These basically flood a network with so much traffic that it completely collapses. Or they'll use ransomware to encrypt your data. The Colonial Pipeline hack is a really prime example of this. They actually ended up paying the ransom simply because the time to decrypt the data was much shorter than the time it would take to restore everything from their backups. Add in some good old-fashioned human error and everyday network failures, and well, you've got a constant battle on your hands.
Section 3. Architecture of resilience. High availability versus fault tolerance. So there's a pretty sharp distinction to make here. High availability, or HA, is all about minimizing downtime. It kind of accepts that a brief interruption might happen during a failure, but it automatically fails over to healthy resources super quickly. Fault tolerance, or FT, on the other hand, demands absolute zero downtime. If a component fails, the system just continues operating right through it without any visible interruption to the user whatsoever. But as you might guess, that usually requires some really heavy and expensive component duplication.
Okay, so how do we practically keep a network operational against all this? We basically rely on a series of interconnected steps. Step 1, load balancers. These distribute network traffic intelligently, so no single server is ever overwhelmed. Step 2, we use digital heartbeats. These are basically health checks that continuously monitor our servers. Step 3, if a heartbeat suddenly stops, automatic failover kicks in, instantly routing that traffic over to a backup system. And finally, Step 4, we rely heavily on immutable backups. These are data copies that literally cannot be altered or encrypted, and they serve as our ultimate disaster recovery safety net.
The really crucial point here is how a business measures its actual tolerance for these outages. And we use 2 key metrics to figure that out. First is recovery time objective, or RTO. That's the absolute maximum amount of time a system can be down before the business suffers totally unacceptable consequences.
Then there's Recovery Point Objective, or RPO, which is the maximum amount of acceptable data loss. So businesses use these two metrics to sort of balance the astronomical cost of downtime against the really heavy cost of building out complex recovery systems.
Section 4. Completing the Triad. Awesome work. We have officially completed the CIA Triad. We started things off with confidentiality, ensuring that only authorized people can actually see the data. Then we moved on to integrity to make sure the data is accurate and totally untampered with. And today we mastered availability, ensuring that the data is always accessible right when it's needed. Together, these three pillars form the absolute, unshakable foundation of all cybersecurity.
Which leaves us with a critical thought to close on. Really think about your own organization's blast radius for a second. If your systems go dark today, will your business survive tomorrow? Because at the end of the day, availability isn't just an IT metric. It is literally business survival. Thanks so much for joining me on this explainer, and I hope this leaves you eager to master the art of cybersecurity engineering. See you next time.